parallel execution. So what is happening in the classroom? In the scenario one, she was checking everything. She collects one paper, finishes it, takes the second one, third one, and so on and so forth. So that's called a serial execution, one at a time. When the kids, it's all together, parallelly. Everybody's correcting at the same time. There's no waiting for anything, just starting to doing this. That's called parallel execution. Same in the big data world. So a big data world is not about a one-man show, a big machine. It's about a team of many machines. It's a cluster which has many machines like these. So there is always a master like the teacher, and there is very much similar, doesn't it look like? There is a teacher which is the master, and there are several students or slave nodes, which are very small nodes. Like the kids, they're small nodes. So what happens, let's say I ask a question to this big data cluster and say, who is the richest person in the United States, right? Let's put that as a question. Bringing all the data, churning through all the data, the master or the one machine trying to do that, that's going to take a lot of time. The way Hadoop implements that, it goes, let's say we have 50 machines in our cluster for simplicity. We have 50 machines, and each of the machines is storing, for simplicity, one state data. One is storing California's data, one is storing Texas data, and so on and so forth. The machine is parallelly going to start doing is it's going to find the richest person in its state. So one answer will get California, one Arizona's richest person, and so on and so forth. Now those 50 answers will be given to the master, and it's so easy after that. Or actually, it will be given to one of the machines. Out of the 50, you just pick the highest one, and you're done. Trying to boil all these things together and things. So that's how it happened in the classroom, and that's what is happening in the cluster. And this is the most important principle. If you read a book, you will read 50 pages just to understand what I'm just going to talk in the next few minutes. But this is the number one thing, parallel execution. It's about a team working together instead of one person. We have one big machine like a Watson. We have small several machines. We can take all of your laptops and make a cluster like that. That's simple machines. That's number one. Data locality. What does data locality mean? Many times in the interviews, people ask this question, what is data locality? So let's go to the classroom first. There are 500 students sitting in the class, and the teacher goes around and picks all their answer papers, right? And carries it home. The time she spends collecting those papers, carrying them home, it's a waste of time. There is no value being produced in that. Not a single paper is getting corrected, graded, right? So that's, from real perspective, it's waste of time. There is no data movement. She's not collecting the paper. The paper sits where it is, and it's getting corrected right at its place. There is no movement and waste. In IT world, when you move data, the biggest bottleneck is when you move data. The I/O problem, which you move data from one place to another. What Hadoop said, we are not going to do this. Let's not do that. Let the data sit where it is, where the students have that. Let that happen. So let's say in my case example, which we had the 50 states, and each machine had one state information. Instead of bringing all the 50 states data into one place and then trying to answer, each machine started processing its own data. There was no movement of data, right? What was happening in traditional world, what you have, you bring the data, you move the data around. Hadoop does it, it moves the program around. I will send one program, complex program, how many lines it is? 5,000, 10,000, 20,000. But it's a file, text file of 20,000 lines, few KBs. That's a very small thing. So why not send that file to those 50 machines instead of bringing their data, so that it reversed the problem on its head. So it started sending the program where the data resides. And that's what is data locality. It means process the data where it resides, as simple as that. Process the data where it resides instead of moving it around. And these two things are the main secret sauce, I would say. The rest are complementary. These are like the other things are just the on the dinner. So these are the two real main calories which you have. So that's the first two. The third is a fault tolerance. But what if these machines fail, which they do fail, right? It's not a reliable machine. It's a small machine. It can fail. Our laptops, if you would go for non-Mac, many times it fails, right? Somehow they manage it to just make it fail after 1 year, so your warranty is off. So those things can happen. So how do we address that? It's great to have all this cluster and all the magic which we just said, but if it keeps failing, that's a problem. So how do we address that? So fault tolerance, how it is addressed. What Hadoop did, or in fact, let's go to the classroom first. What the teacher could have done if she's absent, in the scenario one, everything is stopped. She's not correcting the papers, nobody's getting grades, nobody's moving to the next grade, no scoring, nothing is happening. We don't want our kids to be happening like that, right? In the scenario two, what can happen, you simply put a substitute teacher, and she can easily put an answer paper. That's much easier task rather than correcting thousands of paper. So that's a substitute is possible. That's one thing in the classroom. In the machines, Hadoop, what it does, Hadoop does something called as replication. Think about it as a backup. Let's say you have your passport. What we commonly do, copy of that passport, right? Very common, because we think, yeah, this is an important document. I should make a copy of it and keep. What Hadoop says, everything is important. So if you give me one thing, I'm going to make 2 more copies of it. So totally 3 copies. I'm just going to make copies of every single thing you give me. Doesn't matter. Everything is important for me. Because it has 3 copies and one of the machines, and it will keep in 3 different machines. So let's consider these kids as machines, and the boy with the cap and the girls besides him, let's say are 3 machines. And the California data is not only stored in the cap boy, but also in the other 2 machines for simplicity. That's not how it would actually store, but for simplicity, go with that. Let's say the boy is absent or that machine goes down, you still can get the answer of who is the richest person in California, because that data is sitting with the other 2 machines as well. That's how it takes. If machines go down, I have the data and I can continue processing. And that's how it addresses fault tolerance. So individual machines can fail, but the whole cluster as a thing, it's functioning. It continues to give us the results what we want. So that's the third one. This one is easy, right? The teacher is no more worried. Like, have 5,000 students, 10,000 students, I don't care. It doesn't matter, because they're going to self-correct anyways, right? So that's the scalability she brought in the class. In the Hadoop cluster, what happens, if I need to process more amount of data instead of 50, let's say it's not about the richest person in US, that's about the whole world, the richest person. I'll add maybe another 500 machines instead of 50 machines. So that is called as horizontal scaling. You keep on adding more and more slave nodes, and you are done with that. So that's how scalability is addressed and taken care in this world. This is a little misleading or confusing. Hadoop is free, right? In the open source world, that's why it's free. But it's not because of that it's cheap. Actually, it becomes very expensive because you have to find good resources. Hadoop and big data technology, they're expensive. And running a big data project is not a small thing. It doesn't get over in a week or 2. It takes months and years to really do the whole program. So that's kind of a expensive thing. So why do they say it's economical? They say it's economical because, first of all, if you were to solve the problems of the unstructured data through other mechanisms, it's not going to solve. The other databases are not designed for that. They're not able to solve it at all. So it's not about a question of money or not. Even if you put more money, it doesn't work. If you, let's think your car, if you wanted to fly, just try to make an expensive car doesn't mean that it will start flying. Right? It's not designed for that. So the databases and other technologies, they are not designed for unstructured data. That's the number one problem. But the second part is what happens when you define a cluster which has a master node, like the teacher, and the slave nodes can be cheaper. They can be commodity hardware, which they call. And because each of the server, I'm going to save some money, when I add the cluster's price compared to another cluster, it's going to be much, much cheaper. That's the point. Because it can use commodity hardware and still not fail because it has fault tolerance. So that's kind of the whole secret sauce behind Hadoop and the reasons. I hope the story helps to understand, and maybe hopefully you can, when you have maybe an interview or you have a discussion, you can remember the classroom, and then you'll be able to remain why parallel execution, data locality, why this thing is successful. So that's how Hadoop is able to handle a huge amount of data and process it easily, and keeps on growing as well. So that's in short about the story.